In this video, I will explain how to find the characteristic polynomial of a matrix. So here's the formula that we can use. We can say that P of lambda is equal to the determinant of A minus I times lambda, where A is your matrix and I is the identity matrix. So let's take a look at an example. Let's say we have matrix A here. This is a 3 by 3 matrix, and we want to find the characteristic polynomial of the matrix. So first we need to know what the identity matrix looks like for a 3 by 3 matrix. So the identity matrix simply has ones along the diagonals and 0 everywhere else. So if we multiply lambda by the identity matrix, that just produces a matrix in which there are lambdas along the diagonals and zeros everywhere else. So then if we do matrix A minus lambda times I, here's what we get. Essentially, we're just subtracting lambda from each of the original diagonal values from matrix A. So the last step to find the characteristic polynomial is we want to find the determinant of this. So if we say the determinant of this matrix, the trick that you can use to find the determinant of a 3 by 3 matrix is to rewrite the first two columns of the matrix on the outside of the matrix. Then to calculate the determinant, you multiply the diagonal values from left to right, and then you subtract the product of all of the cross-diagonal values, so the diagonals from right to left. So if you do that, here's what you get. So then we need to simplify this entire expression. So we'll notice that this turns out to be 0, this turns out to be 0, here's another 0, and here's another 0. So here's what we're left with. And then if we simplify a little bit more, we're left with this expression. And then lastly, if we combine like terms, we'll end up with this characteristic polynomial. So this will be our final answer. And one last thing to note is that the reason that we actually find the characteristic polynomial is because if we set this polynomial equal to 0 and we solve for the lambda values, those lambda values are the eigenvalues of the matrix. So that's the main reason for even finding the characteristic polynomial in the first place.